Hey guys, this is chapter 1 notes, section 1, relations and functions. So there's some definitions here at the top in these boxes, which I hope from Algebra 1 days of past you guys are familiar with. I'll let you look at them real quick here, but I'm just going to say this much. A relation, for all intent and purposes, is just a bunch of math. So the question is the relation a function or not? And we're going to talk about that down here at the bottom or further down. Domain, all the x's. Range, all the y's. Again, hope you remember that from the past. So example 1 isn't going to get much easier than this the entire year in Algebra 2, guys. So if we want to name the domain, literally we just have to write down a list of all the x coordinates. So that funky little symbol there stands for a set of numbers, which I am terrible at making, but I'd like to kind of see you guys doing. So the domain, well, what numbers are in the domain? I got a 5, I got a -9, and I got a 6. Now, it would be nice if you would put them in numerical order, but it's not that big a deal. It's just a list of numbers. So the -9 would be the first number, and then the 5, and then the 6. So as far as, like, say, multiple choice exam, for instance, that's the order they would appear because that's the official order that it's supposed to be. So the range is as simple as listing the y's. There's a y, there's a y. There's a y. So I'm going to go with the -7 first, just because it's the smallest number. I'm going to go with that 1, and then I'm going to go with the 3. But domain and range is simple as that. List the x's, list the y's, done. So a function is a special type of relation where the x coordinates don't repeat. Now, there's a much more official definition than this, but that's what it comes down to, and that's what's going to help you determine whether it is or it isn't. So for these next 4 examples, all you're looking for is multiple x's that are the same. And in that case, we'd write no, it's not a function. So for number 1, I see a 2. I see another 2. And keep in mind that's an x coordinate. So no, not a function. Number 2, I see a -1. I see another -1 in the domain, or the x coordinates. So also not a function. Number 3, here's my weak attempt at trying to trick you, is the decimal equivalent of 1/2 equal to 0.5. Yes, so 1/2 and 0.5 are in fact the same. That's a no-no. You cannot have them repeat. So number 4 is just a little interesting. It would be tempting to write a no for this reason. I see a -7, and I see another -7. However, is that the domain or is that the range? So it's a y coordinate that makes it part of the range, and that doesn't matter what happens in the range. All we're concerned about is whether this guy and this guy and this guy are all different, and in this case they are. So yes, it is a function. So this next section down here is just another way of writing coordinates called a mapping. I used to not bother teaching this. Then I realized I was sort of cheating you guys. Like, this is a pretty easy little deal. So put it back in. And it does say in the directions to list ordered pairs, list coordinates. So domain, is the x's. Range is the y's. So if I have an 11, and the arrow literally draws to 0, now that's my set of coordinates. Excuse me, if I have a 9, and it is drawn an arrow to the 6, 9, 6 is my set of coordinates. And then -2 goes straight across to the 3. So more importantly, is the domain all individual different numbers? And they are. 11, a 9, and a -2, all different. And all different is good to go. So that makes it yes, it's a function. So for number 6, I'm not going to list out all the coordinates. That's pretty darn easy. You can handle that. But I will at least illustrate this. On a mapping, if you have 2 arrows, in other words, the 1 is connected to -2, but the 1 is also connected to -1. And pretty obvious that I just wrote down the number 1 twice as part of the domain. Cannot have duplicates in the domain, so that would be a no. So this guy over here, just for future reference, if you hear it somewhere along the way, the guy on the left, number 5, and that's part of the definition had I written it, is called 1-to-1. So in other words, it's one number that connects to one number. But over here, it's not 1-to-1 because this one number connects to 2 different numbers. So to be a function, you have to be 1-to-1. So pretty darn easy, and that's just some warm-up information for functions. So down here, we're going to actually do some math. But given a calculator, I think you're going to like these as well. So how do I find f of -8? Well, notice in the directions there's more than one function. So the f stands for function. But if you're going to have a different one, well, they're not going to say the same letter twice. So they typically call that one g. They would call the next one h. And you can call it anything. Like, let's say, for instance, you were doing a word problem that says something about profit. They would call it probably p of x, or cost would be c of x. But if it's not in word problem form, we're just talking about functions, they usually go with f. But the key here is to know on number 7, since it says f, that means we're using this problem right here. So to find f of -8, I would place the -8 in place of the x. Okay, now I don't need to worry about over here because that's what we're trying to find. I mean, that's what the problem says to do literally. So I'm supposed to take 3 times x, or 3 times something. And in this case, the something is -8. So I just pop it in. And you can pick up a calculator and do that. So, order of operations is all well and good, but we have calculators now that will handle that for us. So I'm going to cut to the chase. And I'm going to tell you, if you type that in the calculator or do PEMDAS, right, order of operations, it ends up being a -31. So again, really the function letter itself is just to tell you which problem to use. So number 8, if I'm supposed to be finding g of 4, I know I'm using this guy right here. But g of 4 is this. So it equals what? Well, that means I have to put the 4 here. I have to put the 4 there. So at the very least, I'm going to write it out. And at the very least, I'd like to see you guys write it out. So I know that you know what it is you're doing. And then I have no problem with you picking up a calculator and doing that. So, in fact, I am going to be lazy. I'm going to do that myself. So I have my graphing calculator handy, and I'm typing a 2, parentheses 4, with a squared, -4, and don't forget about that +5 that's on the end of the original problem. And I hit enter, and it says 33. So nothing to it. Number 9, g of 1/2. Hey, don't let a fraction scare you, especially if you have a calculator. But again, all I'm doing is plugging in right here in for the x in the g problem. So this letter is to tell you which problem to use. So 1/2, square it, -1/2, +5. And I am again going to pick up a calculator and just type that, 2 parentheses. You go 0.5 instead of 1/2 if you wanted to. Square it, -0.5, +5. And the answer to that is 5. All right, so finally, number 10, we have something that's not just flat out easy. So why can't we use a calculator on this one? Well, while I'm plugging in, I'll let you decide the answer to that. But again, I want to use the f problem. And the f problem says 3 times x, or 3 times something, -7. You can always tell people, like, hey, if you're not entirely sure what you're doing on these, like, just leave a blank spot where the x was, because something has to go in place of that x. And this is what they're telling you to put in place. Now, I understand that sounds kind of dumb. You're putting a y in place of an x, but it's like creating a new formula. So I can't type this on a calculator because I don't know what y is. The calculator doesn't know what y is. So all we're going to do is just some simple math. Times them. And then try to subtract them if possible. Well, 6y minus 7, can't do it. Okay, hey, I'm going to do number 12 real quick here. Well, actually, you know what? I'm not going to have time for that. So we'll save the rest of this for part 2 video. Number 11, f of n plus 5 is a little different. Something we're going to get out of ourselves with it. So maybe you should check that one out. And also number 12. And then there's another way to determine functions given their graph. So please check that out in video 2. Thanks for watching.